This tutorial is going to walk us through section 9.4 in the Greenfoot textbook, and it will get us to move the rocket flying forward. The first exercise is to add some initial velocity, and you can always toggle back to the textbook to see exactly what it's reading, but I am going to be mostly just talking you through it. So the first thing we're going to do is add a move method in the rocket's act method, and then we're going to add some initial velocity. And whenever we want something to happen initially, that's going to be in the constructor class. So the first thing that we want to do is to add this move method. I've changed back to the rocket class here. We want to add move into the rocket. If you compile and test that out right now, it does nothing at this point in time because it's based upon the move method in the smooth mover. And just to understand inheritance a little bit, we actually didn't write any move method in rocket. If you look in the rocket class, there is no move method. We have an act method, we have a check keys method, we have a fire method. Okay, and so where's the move method coming from? It's coming from smooth mover, and so that shows us an example of inheritance. This method is inherited into the rocket class because the rocket is a subclass of smooth mover. Now, the move method moves in the direction of a velocity vector. It doesn't do anything at this point in time if you test it out because we have not given a velocity vector when we create a rocket. So we're going to do that. We are going to use the add to velocity method. That add to velocity method is a method in smooth mover, and it takes a vector as an argument, and we are going to create a new vector then, and we'll give it 13 comma 0.7 semicolon. And just as a refresher, and we're going to need another parentheses, what a vector expects, if I look in the vector class, if I forget what those arguments are, which I am forgetting right now, I'm kind of wondering, why do I send it two things? And here it is. I'm sending it a direction and a length. So it says the direction should be in a range from 0 to 359, so that's based upon 0 to 360 degrees. 0 is east, and the degrees increase clockwise. And then length is the length of the vector. So that reminds us or refreshes our memory as to what that vector does. If I compile this now, and we will take a look to see what will happen. It does not, I'm editing some code that I was playing around with, so ignore that error message. We're going to cross our fingers that I can get this. And basically what it does is it gives the rocket some initial drift. So now the rocket starts to drift when the game plays. Next, we're going to try to add some rocket thrusters. And that's going to be this section in your textbook. And the idea is that when we press the up key, we are going to ignite the thrusters. And the textbook talks us through, we're going to add an ignite method when we check the keys. And we are going to define how the ignition works. And basically what's going to happen is an animation. We're going to toggle between an image that shows the rocket igniting and just the plain rocket. I've already written this code, so I'm going to just talk you through it while you guys can type it in. Don't forget to always create a comment for your code. And so you should be writing this code right here. I'm going to explain it while you type it in. So we want a private method because we don't want anybody else to access it. There is no return value, so void is put in as a return type. Ignite is the name of the method, and it's going to bring in a Boolean, and we're going to call it booster on. Now remember, a Boolean is just true or false. So what's kind of nice about that is on the next line I can instigate or implement an if statement that says if the booster's on, then I'm going to set the image to rocket with thrust. And then because I have turned the ignition on, I'm going to give it a boost and I'm going to add some more velocity for it. So the add to velocity is going to create a new vector using get rotation as the direction and 0.3 as the additional velocity. We haven't used get rotation before, but what's kind of nice or kind of cool about that is it gets the current orientation of the rocket. So when we add the booster, it shoots off in the direction that the rocket was already headed. That's kind of a nice thing. Now, if the booster's not on, this else part means that booster on was false. So we don't want to do anything. So we just set the image of the rocket to the regular rocket. And what's going to happen is we want this to occur when we press the up arrow key. So if I scroll up, we're going to check the check keys method. And the check keys method was going to check for a space, which hits a fire, left turns left, right turns right. I am not going to write, though, if greenfoot dot is key down up. We're going to do something a little bit different, and this is the line of code. We are automatically going to call the ignite method, and we're going to send it a true or a false, because we always want to be checking the status of that key. With all the keys, we want to check the status. But this one's kind of nice, so if it's up, it's going to send in true. If it's down, it's going to send in false. And based upon that true or false, it's going to make the rocket look like it's got boosters running. If we take a look at the screen then, I'm going to hit a reset and we're going to run, and I'm just going to show the up arrow key, and you can see that the rockets are bursting, and every time I hit that, it increases the speed of the rocket. So it is moving rather quickly right now. And that is your section 9.4. So what we did was we added a move method to the act. We called ignite from the check keys. We wrote the ignite method. And in the constructor, we called or added the add velocity. This, remember, gives it its initial drift, and it sets the initial values from the smooth mover class. In the next video, it'll be section 5, and we're going to work on colliding with asteroids.